In the 18th century, the mechanization of steam engine inventions in the United Kingdom opened the stage for the first industrial revolution. In the early 20th century, the second stage was a mass production era due to the spread of electricity. The third step since the 1970s was to computerized production automation. We are now entering the fourth industrial revolution, centered on smart factories with IoT and AI. With the diversification of product needs demanded by consumers, demand for facilities for mass production of multiple products and variable volume production is increasing. Based on the three concepts of speed, small, and saving, the world's #1 winding systems from Nittoku Engineering support the construction of smart factories through highly unique technologies such as control technology, transport technology, and handling technology. In order to develop the know-how cultivated through winding technologies into the next generation FA systems market, Nittoku Engineering offers the creation of new production facility lines that combine modules with original FA systems. A module is a combination of hardware and software into a single general-purpose unit. In order to cope with the variable volume production, we have adopted a modular structure. We combine the transport modules that form platforms with the processing modules and handling modules that form elements to build autonomous production lines that are optimal for customers. Replacement of modules enables the rebuilding of lines, specification changeovers, and overhauls. Here are some examples of modules. Nittoku's original track trace robots are combined with vision modules to enable a wide variety of products to be supplied. A vision-based check module was combined with a proprietary coding module to enable highly flexible coding and check feedbacks. Nittoku's proprietary FA-based system, LITS, is one of the most important transport modules in the construction of production lines. The first major characteristic of LITS is that it's capable of precision processing on conveyance. Second, high-speed linear horizontal conveyance enables pitch feed of carriers in a short time. Third, flexible design is possible depending on the type of production. LITS supports loads up to 5,000 newtons. LITS, which combines the advantages of free flow and table index, is excellent for operation adjustment and maintenance, and is easy to handle magnetic materials which are not suitable for linear motors. In addition, it is an innovative FA-based system that enables a variety of line concepts, including pitch conversion, pallet rotation, vertical circulation transfer, and shuttle transfer, and dramatically improves productivity. One of the key parts required to make next-generation production lines more visible is the intelligent tag system developed by Nittoku. The first major feature is that large-capacity data can be rewritten more than 1 trillion times. This makes it possible to build a large-scale distributed control system. Second, it offers high reliability communication performance. This is achieved by the unique winding technique of Nittoku, enabling stable exchange of data. Third is high-speed processing. Reading and writing 128 bytes of information are realized at a speed of 0.07 seconds. This is more than double that of conventional products. The antenna and reader-writer can be miniaturized and wiring can be saved, and they can be easily installed in the equipment. Here are some examples of the use of RFID tags. This is an example of a hairpin motor in a forming process, which is one of the EV/HEV motor construction methods. Along with the production of multiple hairpin shapes, there are also multiple forming modules. This hairpin method requires more than 10 different types of rectangular wires. Mounting of the RFID tags on the forming jigs allows automatic determination of whether the correct die is used. This makes it possible to efficiently form a single hairpin without mistakes. The second example is used in the production process of wireless charger coils. Attach RFID tags to the pallets to control the process. No material loss or machining loss will occur because the workpiece written as defective in the previous process will not be machined, as it will be judged at the time of reading in the next process. FA tags are used when the QR code cannot be printed, or when a separate controller is used for each process. The FA tag is also valid for a multi-axis production line. In the future, machining and assembly can be carried out in every process based on the manufacturing instructions written in the RFID without human intervention. Eventually, the information written in each process is aggregated into the upper database via the edge server and becomes available for traceability. In next-generation vehicles, motors used in EVs and PHVs are effective in reducing CO2 emissions and consume less than half of gasoline-powered vehicles' energy. In order to make the motors used there better, Nittoku is developing a new winding method. This time, we introduce the unique EV motor winding line of Nittoku that employs LITS shuttle-based transport and incorporates winding modules with tuning sensors. This is a revolutionary winding method, which is completely different from the conventional inserter method. Firstly, in the winding section, fully layer-aligned winding of multiple wires is carried out with an air core. Check by sensor whether the winding is crossing at this time. It is programmed to autonomously stop and adjust in the event of a winding cross. The advantage of the new construction method is that electrical defects can be greatly reduced. In the inserter method, the crossing of the electric wire is generated in multiple places when the electric wire is inserted, whereas in the new cassette method, wire crossing is severely limited. As a result, we were able to eliminate the damage to the wires and the degradation of the insulating film that occurred during winding process. This is because the load applied when inserting the wire by the inserter method is 1,000 kilograms to 2,000 kilograms, where the cassette method allows the wire to be inserted to the slot with a load of about 10 kilograms. In addition, there is a merit that primary and secondary forming in U phase and V phase is unnecessary in the line configuration. Increasing the fill factor and reducing coil damage, coil end, and coil circumference with the new construction method leads to a reduction in the defective rate, downsizing of the motor, reduction of heat generation of the motor, and reduction in the amount of copper used. Nittoku will continue to deepen its partnership with customers worldwide, create new product values, and contribute to the creation of comfortable and prosperous societies through innovative winding technologies.